In this example, we have a triangle ABC. We're given the vector AB and we're given the vector BC. Our task is to show that angle BAC is 105.9 degrees to one decimal place. So we know the vector BC. I'm going to change pen color. So we know the vector BC and we know the vector AB as well. And we need to show that the angle BAC, which is this angle here. So BAC gives me this angle. We need to show that is 105.9 degrees. Well, the best way to do that, I think, is to use the cosine rule. We're going to need the lengths of all three sides. We can quickly find the lengths of BC and AB because we have their vectors, but at the moment we can't find the length of AC. So the first thing we need to work out the lengths of AB and BC, and then in a moment we'll work out the vector AC. So here are the lengths of AB and BC using 3D Pythagoras. Now let's work out the length of vector AC. We're looking at the diagram. We want to start at A and finish at C. So we can travel forwards along AB and then forwards along BC. So AB plus BC will give me the vector AC. And there it is, AB plus BC turns out to be 3 minus 6, 4. Now we have the vector AC, we can find the length AC. So we have the three lengths of the three sides. Don't turn them into rounded decimals, leave them exact. We're now ready to use the cosine rule. I'm not going to go into the details of rearranging this, but there is the cosine rule at the top, and then we sub in everything we know and rearrange it. Do remember that the angle capital A needs to be opposite the side lowercase a. Now it's lucky here that the angle we're working with, well, it's not actually the angle, it's the point, has the label capital A, which means less chance for confusion. But if these had different names, then still just think of that as being angle capital A, and this is side small a. So this was our side BC, and it had length root 91. So the most important thing is that the 91, which comes after you've squared it, is the one that's over here. The other two can go either way around, but the 91 must be there. Then when you rearrange it, I get cos of the angle BAC is this thing here, which if you want it as a decimal, it's that. But I just leave the unrounded version on my calculator screen and then do inverse cos. We need to be working in radians. Sorry, no, we need to be working in degrees, if that's what the question wants. So make sure your calculator is in degrees, do inverse cos of that, and you should get the correct answer.